Hello class, in this video I'll be providing definitions for the absolute maximum and absolute minimum of a function. Let's begin. So we're going to let f of x be defined on some interval I. If there's some number r such that f of x is less than or equal to f of r for all x in the interval I, then f has an absolute maximum at r, and f of r is the absolute maximum of f on I. Okay, moving on to the absolute minimum. If there's some number r such that f of x is greater than or equal to f of r for all x in the interval I, then f has an absolute minimum at r, and f of r is the absolute minimum of f on I. Now, if you were reading these definitions and you thought to yourself, man, these sound awfully similar to the definitions of local maximum and local minimum, then you'd be absolutely correct. However, there are some major differences between the two, and I'm going to go over them right now. All right, so the biggest difference between the two is that local mins and maxes only occur if an open interval can be placed around the location. Absolute mins and maxes can occur on any interval. All right, so let's take a look at this graph here. Here is the location of two local maximums. And that is because I can place open intervals around those two locations, and the output values at those two locations are the largest in those intervals. So we have a local maximum here and a local maximum there. Okay, we have a local minimum right here. And again, that's because we can place this open interval around that coordinate, and the output value at that coordinate is the lowest in that interval. Okay, absolute mins and maxes can occur on any interval. So let's take a look at this graph one more time and notice that there's going to be an absolute maximum in exactly the same location as the local max. And that's again because I could place an open interval around that coordinate, and it is the highest output value over the entire domain of this function. So this is also an absolute max. Okay, now there is an absolute minimum, and the absolute minimum is located right at this endpoint. And that's because I can place a half open interval like that where the closed side lands on the endpoint. So the absolute minimum of this entire graph is located at the endpoint. Okay, number 2. Endpoints cannot be local mins or maxes because an open interval cannot be placed around them. Okay. So what does that mean? That means that if I try to place an open interval around that endpoint, the function does not exist in this domain. And if I did the same thing here at this endpoint, try to place an open interval around the endpoint, the same thing occurs. The function doesn't exist in that part of the domain, which means there's nothing to compare this endpoint to in this part or in this part. So endpoints cannot be local mins and maxes because we can't place open intervals around them. Okay. Number 3. Endpoints can be absolute mins and maxes because a closed interval can be placed at the endpoint. All right, so just like we saw in the first example here, I can place a half open interval right there where the closed side is the endpoint, and we can call this the absolute maximum. And the same thing occurs here at the other endpoint. The closed side can go right at the endpoint. And we can let the endpoint be the absolute minimum. Okay. Number 4. Any function that increases without bound in the provided interval has no absolute maximum. Okay, so in this case, there's clearly an absolute minimum here, and this absolute minimum happens to be a local minimum also. And since this function increases without bounds, there is no absolute maximum. Okay, and similarly for number 5, any function that decreases without bound in the provided interval has no absolute minimum. All right, so in this case, there is an absolute maximum, which happens to also be the local maximum. So there's a local maximum here, which happens to also be the absolute max. But since this function decreases without bounds, there is no absolute minimum. And we are done.